Hello. Um, this these are your video notes for today's lesson. And all we're really doing, the main focus is you guys have done translations, rotations, reflections. We talked about dilations on Friday. So essentially, what we are doing today is we are going to go through and talk about doing transformations one after the other. That's where we're going. So, describe the sequence of transformations that map the pre-image to its first image and then to its second image. So, this is my pre-image, which is going to go here because as you can tell, actually I'm going to do that in a different color, so we have two different colors operating here. So this is the first one we're going to do. And you can tell because it's going from C without an apostrophe to one apostrophe. And then the second one we're going to do is from here to here. Okay, so I'm looking at this and I'm seeing that it stays in the same orientation. I'm saying it's not flipped over. I'm seeing it's no bigger or smaller. This to me is just a translation. So the first translation we're going to do, I'm going to write transformation number 1. So the first transformation, it looks like we are going right to 1 down. Which you could write as a coordinate rule. Or you could write it as a vector. That's transformation number 1. Transformation number 2, it looks like we go right 1 and up 2. Which, if you were going to write the coordinate rule for that, and then x plus 1, y plus 2, or you could simply do it as a vector and say 1, 2. Okay, so first we went right and down, and then we went right and up. There we are with that. That was translations. That's not too bad. This one, it doesn't change shape. I do notice, here's the thing I noticed. I noticed that this side, this vertical, is now horizontal, which indicates to me that that's probably a 90-degree rotation. I will check the points to be sure. And then when I look here, and I look down below, it looks like this is actually flipped over. So I'm guessing that it's rotation and then reflection. And I know which one is first. The one that's first is from here to here. I'm just going to check one thing. Point E is at 2, 1. And E prime is at -1, 2. So that is XY turning into -y, x. And so, yeah, that's a 90-degree rotation. Yay! Okay, so got that one right. So put that to the side for now. And transformation number 1. Is going to be a 90-degree rotation. About the origin. And if we were going to write this in notation, we would write it as RO 90, and we're going against the clock, so this is counterclockwise, which means positive. And there we go. That's the first one. Then I am going to look at the second one. And what I'm noticing is that f prime and f double prime are both the same distance away from the x-axis. So that is the reflection. And that would be reflection across the x-axis. And if I were going to write that in notation, I would take d prime, e prime, f prime, and I would reflect it across the x-axis. So notice this one they both had r's. We're back to this again because this is troublesome for a lot of people a lot of the time. If you notice, they both have r for their big notation, but when you are doing a rotation, you're going to have a 90, you're going to have whatever, but you're going to have some amount of degrees. When you are doing a reflection, it'll tell you which line to go across, and that's how you know which thing is doing what. Okay, so we're going to do these transformations in their order. All right, so same two transformations. Have you noticed that? So this is my pre-image right there. Actually, let me just think about it. I'm just going to highlight that in blue. This is the pre-image, right? So the first thing I'm going to do is I am going to rotate it. That's number one. So number one is a rotation of 90 degrees about the origin. Okay, so remember, one of the things you're going to do in order to go around the origin is to change all your points to negative yx. And that's actually how I'm going to do it. So point A was 2, 8. So negative 8, 2 would be A prime. B was located at 7, 6. So that would become negative 6, 7. Right here. And then C prime is at 7, 1, so negative 1, 7. Right. 7, 2, so negative 2, 7. Whoop, that's 3. Hold on. Right here, C prime. And so here is the first one. There's your first one. Okay. So that is your first image, and then I'm going to translate it. That one's going to move 3 right, 5 down. Okay. 3 right, 5 down. So C prime goes 1, 2, 3, 1, 2, 3, 4, 5. So here's C prime, double prime. Ooh, that's C double prime. How about that? Let me make that a little bit clearer. All right, B double prime, 1, 2, 3, 1, 2, 3, 4, 5. And this is B double prime. And then A double prime, 1, 2, 3, 1, 2, 3, 4, and 5. Connect those dots. And there we have that. And I am going to go and why can't I do this? There we go. And so here is the final image, A prime, B prime, C prime. Okay. So that is what it looks like when you rotate it and you follow that with a translation. Okay. So the next thing I'm going to do, let's switch them up and see what happens. All right. I'm going to translate 3, -5. And this is the same thing we just did. So what's going to happen with this one is 3 right, 5 down. We're going to do that first. And then we are going to do the 90-degree rotation, which all the points from the first transformation will go -y, x. All right, so here is my pre-image, same pre-image as we had before. The only difference is we're switching the order of the transformations. So 3 right, 5 down. 1, 2, 3, 1, 2, 3, 4, 5. So here is C prime. 1, 2, 3, 1, 2, 3, 4, 5. Here is B prime. 1, 2, 3, 1, 2, 3, 4, and 5. Here is A prime, and I'm going to connect these dots. And so this is the first image, image number 1, okay? That is the image that we have to rotate 90 degrees counterclockwise, okay? So 90 degrees counterclockwise, remember, -yx. So 1, 2, 3, 4, 5, 1, 2, 3. So 5, 3 would become -3, 5. Right about here. And that would be A double prime. Okay. B is 10, 1, which becomes -1, 10. And that's B prime. And then C prime is 10, -3. So that becomes +3, 10. And that's C double prime. And so here we are with these particular, with these things done. Okay, so there is my ultimate image. This is the big one that I was working on. So here's what I want you to look at. There's a question right below. It says, does the order in which we perform transformations matter? So if you look at where these two wound up, here and here, I'd say it very much does matter which transformation you go first. They're not going to wind up in the same spot when you flip the transformations. One transformation, it matters. It matters. So does it matter? Oh, yes. Yes, it does. So that is the situation with this. And all you're really doing is looking at all of the transformations that you would have had. Writing a composition of transformations is essentially putting two transformations in a row. So my first transformation here is 2, -1. It's a translation. And here, this one is 4, 3. Now, here's the thing about this. We've kind of talked about this before. If I do this, you've actually gone a total of x plus 6. And then -1 plus 3 is 2. So 6, 2 on that one. That's your single transformation, actually. On this one, I'm starting with 2x and 2y, right? So this first one is a dilation multiplied by the same number both times by a scale factor of 2. And this is, actually, you guys may not recognize this. We didn't do a whole lot of work with it. So this is a reflection across x, y equals x. That's what happens. That's the inverse line, and all you do is switch their places. So that's what we're doing. So the first thing is I'm going to have the 2x, 2y, and then I got to switch them. So what is going to wind up happening here is we're going to have 2y, 2x. That's going to be how you plug. That's your coordinate rule. If you're going to write this out in a series of transformations, it's going to be hard to say because they're not both the same thing, so you can't combine them. What I'm going to do is say the first thing we did was the dilation by 2. And then there's this little open circle, and here's where you put reflection across y equals x. So let's talk about that open circle. The open circle is something you're going to see next year. It means function composition, and it means you're putting one into the other. It's input output. So essentially, the first thing you did was the dilation, right? That was transformation number 1. And then you take whatever you got from that, and you do transformation number 2. So this was the first. This was second. When you're doing function composition, you always do the one after the dot first. Here's this last one. Okay, I do have a dilation. Also by 2. And now I am combining that with a translation of 4, -3. So that's going to be what I wind up with is 2x plus 4 and 2y minus 3. If I was going to write that out, we do translation. No, we wouldn't. I was wrong. Dilation is the very first one. So dilation by 2. And this is a translation. Let me write that a little farther away. Translation 4, -3. All right, so that's what it would look like in function composition. And again, the one that follows the open dot is always the first one you do. I wouldn't worry too much about the notation. I just wanted you to see it. What would be important is that you'd know what to do with the points. You'd multiply and then you'd move it. Okay, so first you would multiply by 2, and then you would move right 4 down 3 for that last one. So this is all about sequences of transformations. Tomorrow you'll work with a bunch of problems on that. You do have homework tonight. It's day 8, and I will hopefully see you tomorrow.